Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 11 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2843. Count symmetric integers. Let's read the problem statement first. You are given two positive integers low and high, an integer x consisting of 2 into n digits. Okay, that simply means even number of digits. Okay, is symmetric if the sum of first n digits of x is equal to the sum of the last n digits of x. Okay, numbers with an odd number of digits are never symmetric. Okay, so we have integer x consisting of 2 into n digits. Okay, n is 2, so let's say we have 8 7 and here 7 8. Okay, so 2 into n. Okay, so this is n and this is n. All right, so an integer x consisting of 2 into n digits. Okay, this is nothing but 2 into n digits overall is symmetric if the sum of first n digits of x, okay, complete, of x is equal to the sum of the last n digits of the x. Okay, and numbers with an odd number of digits are never symmetric. We have to return the number of symmetric integers in the range low to high. Okay, and see here, constant size is very important here. Low is from 1 and high is until 10 to the power 4. Okay, so we are only considering even number of integers, right? So that simply means we have numbers from 11 to 99. Okay, we have to check these numbers. We are not going to check odd numbers from 100 to 999. We are not going to check that. After that, we are going to check the numbers from 1000. Okay, 1000 is 4 digit, right? To where we are going to check until 9999 until here. Okay, so this is going to be the range that we have to check. We have to check the numbers from 11 to 99 and we have to check the numbers from 1000 to 9999. Okay, 10 to the 4. Okay, highest, this is given to us, right? So here, okay, so here in 11 to 99 we have numbers like this 1 1 2 2 3 3 4 4 5 5 6 6 7 7 8 8 9 9. These are all symmetric, right? So these are nothing but the multiples of 11, right? So here 1 to 100, if you see in this range, 11 22 33 44 55 66 77 88 99 are symmetric, and these are all the multiples of 11. That's it. So this is going to solve one part. Okay, in this range we will check if the numbers are divisible by 11, then that means that these are the symmetric integers. Done, this is done. Okay, now let's come to this 4 digit size. Okay, this one. All right, so here see this example number 2, 1200 to 1230. Okay, so here we have to check all the numbers from this 1200 to 1230. Okay, so we have to check all the numbers. First I will check 1200, then I will check 1201. Okay, then I will check 1202, then I will check 1203. Okay, and so on. Then I will check 1212, then so on again. Then I will check 1221. Okay, 1222, 1223. Okay, and then until 1230 we have to check. Okay, so in all these numbers, if you see here, this 1203. Okay, first two digits sum is 3 and last two digits sum is 3. Okay, this is valid. Then here first two digits sum is 3, first last two digits sum is 3. This is also symmetric. Then here this is also symmetric. Okay, last two digits and first two digits sum is 3. This is also symmetric. Okay, so this 4 is going to the output in this range. Okay, all of the numbers, see here 3 and here 2, that's not valid. Okay, so now how we are going to solve this? Okay, how we are going to get the left part and the right part integers? Okay, so very simple. Okay, so let's take this number 1230. Okay, 1230. Now I need the left side of this. So left side, but you need to do here, this is your number 1230. Okay, let's say this is nothing but a. Okay, so I'm saying you have to divide a with 1000 first. Okay, then after that you have to take the remainder after dividing a with 1000. Okay, and then again divide it with 100. Okay, so this is a formula that I'm saying that you need to do. Okay, so now let's verify. So here your left is going to be a divided by 1000. A, put this value 1230. So 1230 divided by 100. Okay, 100 1000. So what you are going to get? You are going to get here 230 as the remainder, right? 230 as the remainder, and this is the value. Okay, so when we divide a with 1000, we are going to get this value, right? 1. So here from this side we are getting 1, okay, and then here a divided by 1000, okay, more a modulus 1000, we need the remainder here, so we are going to get 230, and then 230 I am dividing it with 100, okay, I am dividing it with 100. What I will get, I will get 200 remainder as 30, and here the value is 2, okay, so I will get 2 here, right? So here 1 plus 2, what is the value that I am going to get for the left side? 3. That's it. So this is correct sum, okay, correct sum, 1 plus 2, okay. So a divided by 1000 is going to give me the left side value, okay, and a modulus with 1000 divided by 100 is going to give me this side value, okay. So this is the formula, right? Okay, this is how I will get left, okay, this formula. Now to get the right side, so what you need to do, you have to write a, okay, a is nothing but your number, whatever the number you have, a modulus with 100, and then divide it with 10, then here a modulus with 10 you have to do, okay, a modulus with 10. All right, so now how we are going to get this 3, okay, how we are going to get this 3? It's very simple. So here whatever your number, okay, 1 2 3, so 1 2 3, if you divide it with 100, okay, so here for one time you are going to write here 100, okay, then here 2 3, and then here 230, 0 will come down, and here 2, okay, so here you are going to write 200, right? So here remainder is 30, okay. So here what you need 30, and 30, then 30 you are dividing with the 10, okay, 30 you are dividing with 10, okay, this, so 10 3 30, okay. So here you need these 3, okay. So from right side here you are going to get 3, okay, and here a modulus with 10, so a modulus with 10, 12 30, just divide it with 10, okay. So 10, you are going to get here 10, okay, here you are going to get 2, and then 3 here, then here 20 you are going to get, and then 3 here 0, and here you are going to write 3, so this is completely divisible, right? So you are going to get here remainder is 0, right? So from here you are going to get 0, okay. 3 plus 0 is 3 overall. So now after that, here we are summing up the left side values, here we are summing up the right side values. 3 plus 0 is nothing but 3 here, and here also 3, right? Both sides we are getting 3 3 only, right? So both are matching, so that simply means that this is one valid output, okay. This is symmetry, okay. So just increment the count. So this is a simple formula that we have to use, okay, left and for right, okay. Now let's move to the coding part. It's very easy, nothing complex, right? So constant size matters here in this program, okay. So int result is equal to 0, right? And then after that just run one loop, int for loop, okay, for int a is equal to starting from low, all right, and a it should be less than equal to high, okay, high is inclusive here, all right, and here a plus plus, all right, and here inside this just check if the your a value is less than 100, and a modulus with 11, okay, completely divisible by 11, okay. If it is equal to 0, then simply increment the count of result, okay, result plus plus, done. All right, now this is for 2-digit integer, okay. Now let's move to the 4 size integer, right? So here in the else part you have to write else if a value it should be greater than or equal to 1000, right? And a should be less than 1000, okay. This range 10,000, okay, 9999 until there, right? So inside this for 4-digit integer we have to calculate the left. So left, how we are going to calculate leftmost integer we need? So for that just a divided with 1000, okay, and then second integer, to get the second integer you have to do a modulus with 1000, okay. Then you're going to get the remainder as like here 230, then you need 2 now, so for that you have to divide it with again 100, okay. So now this is how we are going to get the left side value, okay. And now how we are going to get the right side value? So right side is equal to we need this 3, okay. So in order to get this 3, first we are going to get the remainder from a modulus with 100, okay, and then we are going to divide it with 10, okay. Then after that we need last value, so simply a a more or less with 10. That's it. Okay, this is going to give you the last value. Okay, then here just check na, if left is equal to right, then in that case just increment the count of result. Okay, result plus plus, right? That's it. Okay, and here this ends, here this for loop ends, and here you have to just return the result. That's it. Okay, so easy, right? Now the time complexity is going to be of high minus low. Okay, because we are just covering the integers from low to high, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.